morning, good afternoon, everybody, and welcome to the TIBCO Analytics Meetup. We'll be covering topics on TIBCO Analytics and data science today. The usual confidentiality disclaimers. I encourage everybody to formally join and register in the TIBCO Analytics Meetup. We've got almost 700 members now. And if you join up to the Meetup group, you get automatically the downloads, the slides, videos, details about upcoming events, things like that. So please do that if you want to get all those assets. Today, I'm going to give a welcome and update. We're going to segue into a couple of demonstrations from Thomas, a new data function for calling Statistica from Spotfire, part of the TIBCO data science suite. And then David, who will be talking about anomaly detection with a deep learning autoencoder, also called from Spotfire. And Helene will wrap up with a community update. You can submit your questions at any time via the Q&A option, and we'll answer those at the end of the session or get back to you via email. So just a little bit about the TIBCO DNA. We're all about finding and acting on critical business moments. That's where the value is, whether you're delivering proactive customer service or predicting impending equipment failure, optimizing pricing, detecting anomalies, preventing fraud, things like that. Today, our case studies are in the area of anomaly detection and risk management. And we're going to be covering some of the portfolio of products, our connected intelligence portfolio from the Augmented intelligence side of the house, where we have products in data management, data science, data visualization, combined with some of our interconnect products around API management, messaging, event processing, and process automation, BPM. We take a portfolio approach, so we combine these products, and you'll see today the combination of visual analytics with data science. We've been covering the combinations of those with streaming and virtualization in previous sessions. Our products are tightly integrated, but loosely coupled. They're available anywhere and everywhere in hybrid, cloud, and on-prem environments. And we have a number of accelerators, cloud starters, and applications to get you going with these closed-loop continuous learning applications that we put together with our products. Some of those closed-loop applications include anomaly detection, as I mentioned, we'll be focusing on today, risk management, customer engagement. These are business-focused TIBCO applications that have data science embedded in them with configurable visuals, data science, low-code components available in cloud or on-premise. And these, you can download some of these from our community exchange, which Helene will talk about at the end of today's presentation. But today we're focused on TIBCO data science and going through that process of connecting to data sources, modeling, and pushing models out into operations and feeding those into business applications. In today's case, anomaly detection, which is a common design pattern for predictive maintenance and so on. These cover personas from all the way from data engineer to data scientist to citizen, data scientist, business user, IT, and so on. Now, our data science offering, we have unified our authoring components. When you purchase the data science application, you can mix and match Statistica, which Thomas will be demonstrating today with our Teams offering, which is the evolution of what we built with Alpine. And you can run on the server in a distributed environment with cluster compute through Hadoop, Spark, other database structures, or you can run locally on your machine in the core here. And we pull in various ecosystem libraries, including our own TIBCO R service. You get comprehensive data access, native cloud authoring, integration with the cloud-based ML vendors. You have this model management, collaboration, governance, automation on the server, and on the client, a combination of visual drag and drop with notebook components along with automation and so on. A pretty comprehensive stack that we offer as a TIBCO data science. Now, the Teams component of TIBCO data science includes a heavy emphasis on collaboration. You can set up projects of people, connect to your corporate data assets, build workspaces and workflows, deploy those into production operations. all through this teaming collaborative environment. The algorithms are scalable. We don't move any data here. It's in database, in data lake, data prep, analytics, and machine learning, Python notebook and PySpark APIs, automatic tuning of the Spark cluster, and then both web visual as well as notebook composition. So being able to drag a notebook onto the canvas and combine notebook with the drag and drop environment. Again, both our own components as well as integrations with Amazon, Azure, and the others, both the data sources and being able to call into their libraries. Now, today's demonstration from Thomas is from our Workbench Statistica local environment. This is a product been around for a number of years, lots of stats and machine learning. Thomas is going to show how to configure calling out to a Statistica workspace and algorithm from Spotfire. Now the rule and model lifecycle management for the workspace and the models is a feature of this offering as well. And then wherever you construct your model, if it's on the Teams distributed web environment or if it's on the local Statistica Workbench environment, being able to deploy those out into a daily operations or real-time operations, either through batch or real-time scoring, including the inbuilt capabilities as well as R or Python, and then managing that models in production, connecting to streaming data, scheduling batch runs, pushing out predictive insights into a business analyst environment like Spotfire, which you'll see today. So this ability to publish out models either in PML or PFA or containerized models into a cloud environment for taking this data science, machine learning patterns and pushing those into a cloud-based application, or pushing the data science model out into our artifact management server where it's modeled and versioned for deployment into our event processing environments such as TIBCO Streambase. So a number of options here for combining data science with streaming. We've been recognized by both analysts and partners alike. We're the only, TIBCO Data Science is the only data science platform that has accreditation from AWS for both data services or data prep, feature engineering, along with a complete end-to-end platform solution accreditation. And even the algorithms that we are showing you today are available through the AWS marketplace. Now, the combination of data science with visual analytics is particularly powerful. And you'll see that today as both Thomas and David show you ways of sitting inside of Spotfire and calling out to algorithms and workspaces from TIBCO Data Science, R and Python. Now we're particularly excited not just about our data science products at the moment, but also the new release of Spotfire, Spotfire 10, written X and pronounced 10. That includes inbuilt AI and machine learning, this augmented analytics experience that we have in Spotfire 10, automated data flows and being able to edit the data lineage that's automatically generated by Spotfire, along with real-time insights for visual analytics on a data stream built into Spotfire. Also, the interface has been reimagined for casual users and data scientists alike. So just a couple of highlights of this before I hand off to the guys. It's pretty quick to build out some really compelling and valuable visual analytic applications that address a variety of industry problems, quick to configure these applications inside of Spotfire, strong geoanalytics capability that's configurable not just to geography, but process maps, weather optimization, like worker task pairing type situations, building out these full-featured visual analytic apps in a variety of industry settings. Now we've added in Spotfire 10 this AI engine for recommending visuals to put into an analytic application. When the user selects a target variable, we have already figured out all the relationships of that target to the other variables in the data set, and we display those relationships in order of strength with the appropriate best practice visualization and in a thumbnail of the data that you just have to click and add into your dashboard. So four or so links to get a brush linked dashboard as part of your analytic application. And we are calculating those relationships in a separate thread behind the scenes and doing all those calculations in the background. Now you can also search, type a question answer type session to Spotfire and build up your analysis without going into any of the menu systems. And again, the recommendations for the relationships based on your question that you ask Spotfire are sorted in order of strength and so on. So combination of both the AI recommendation engine with your natural language query back and forth with Spotfire, where you can construct the brush link dashboard entirely from a chat-based interaction. The data mashup and data wrangling I mentioned, you can either point and click to prep your data, or you can write some expression type code to calculate new columns. Whatever you do in the point and click environment or the coding environment is automatically trapped into this data lineage from start to current state of the dashboard. And you can go back into that data lineage and edit the transformations upstream, and all of the calculations flow downstream. So whatever you're doing up here in point and click is being reflected in the data canvas, and you can use that as a point of entry for updating your analysis. Predictive and machine learning, this is the focus of today's presentation. Thomas is going to use call TIBCO data science from Spotfire and bring the results back. David's going to call our inbuilt TIBCO runtime R engine from Spotfire, bring the results back. We can also call into Python. These compute engines run either locally or on the server. And finally, the data streams. This is a new feature to Spotfire 10, where we can visualize real-time data streams, things like JMS, Kafka, whatever your source of data might be. We can feed it up into a Spotfire data stream analysis where the visuals are updated incrementally. And there's lots of data sources supported. You can point and click between the real-time updating visuals and the historical visuals, just like you do with any other marking that you create inside of Spotfire. So putting all that together, the classic brush linking that we offer in Spotfire in spades, data mashup, data wrangling, the recommendations engine along with natural language query, the real-time data streams, one-click web deployment, along with a lot of strength in geo analytics and predictive analytics, along with our server-side strength in governance, security, configurability. These are the real strengths of Spotfire. Now we're going to show you this combination of Spotfire with our TIBCO data science offerings in the context of a case study around anomaly detection. Now anomaly detection is everywhere in IoT and engineering. We do quite a bit with the Formula One, in the energy sector, predictive maintenance, manufacturing, all these engineering use cases, but it's a key use case in many other areas. So in financial services, fraud detection, trade surveillance, in healthcare, monitoring patient risk, customer analytics, churn prevention, cross-sell. Anywhere where you want to do surveillance across a system of data, find an issue that's concerning or an opportunity, and make an intervention in the way of an offer or a calling a engineer to go, field engineer to go and fix some equipment. This type of insight to action is part of this use case. Now you'll see Thomas and David today. David's going to, well, Thomas first is going to demonstrate Spotfire with TIBCO data science, the Statistica workbench in the context of a cluster analysis where the distance to the closest centroid is the measure of the anomalyness of the observation. David's going to show an autoencoder, the data function calling out from Spotfire. And there the reconstruction error is the measure of the anomalyness from the deep learning autoencoder. In both cases, we get features to drill down into the root cause, and the models can be used for scoring a new event stream. We have a number of accelerators and templates available for download on our community site. The anomaly detection template for Spotfire that David will show, and a couple of accelerators for risk management and manufacturing that are available on our community site. And we're pretty excited about the work we did this past year with the Mercedes F1 team, where anomaly detection was a key component of that work, and all of the work that we have going on in the engineering side of the house and the finance and customer side. So with that introduction, let me hand off now to Thomas to take you through the demonstration of TIBCO data science with Spotfire. Thomas?
Yes, thank you, Michael, for introduction. Maybe you, yeah, thank you.
My name is Tomasz Jucik and I'm data scientist in TIBCO. We know that TIBCO Spotfire is a great interactive visualization tool, and in addition to that, it has possibility to use data functions, which means it can call external scripts, which can do additional analytics and compute additional results, which can be visualized in Spotfire. You might have already used R, TER data functions or Python data functions, which are about calling scripting languages directly from Spotfire. But today, as was said, we will discuss and show another type of integration now with the TIBCO data science and more precisely with the Statistica component. So we will show you how to use and construct a Statistica data function. The difference is, as you will see, that in Statistica you can build your data function without need of scripting and only using graphical workflows. So the objective of this part is to demonstrate via build from scratch example how this Spotfire Statistica integration works. So at first we will build a simple workspace in Statistica, a graphical workflow, and then we will call this workspace as a data function in Spotfire on a completely different data set. And then we build some visualizations on the information which we get from this data function. So let me jump to Statistica to introduce it a bit. So Statistica is an advanced analytics platform where you can implement the whole data analytics workflow, starting typically with data loading, data cleaning, data transforms, continuing with application of various statistical methods, which are giving some insight from your data. You can build predictive models and you can save the results. What you can see here on the screen is an interface called Workspace, where you can implement your data science workflow. Each node is one functionality of the software, and nodes can be logically arranged one after each other according to what you want to achieve. So Statistica is also known that it has a huge amount of functionalities and options, which means that there is also huge base of building blocks for data functions in Spotfire. So let us start, not with that sophisticated example, but with something simple. So we will build our workspace from scratch. We are opening blank workspace and we will insert here file. Let's say this file. It's data about the wines. We have 178 wines and some properties of the wines. Let us rename it to data. And then we will be choosing the functionalities which we need to build our workflow. So at first we will need a node for selecting variables. This will select variables for the next analysis. And in our example, we will do simply a clustering example. So let us define the nodes. First, we need to choose variables. We are choosing star, which means that all variables are chosen. This is important. When you write star, it means exactly that. This is important because later on we will have a different data source. So selecting all variables is really important. It's not dependent to the data which we have here. In a clustering node, we can define various parameters to initialize the algorithm. We can maybe use more detailed output, and we in the second tab we will choose that we want the cross validation, which means that algorithm will choose by itself what is the optimal number of clusters. So let us run it, and it will compute the clustering. So it will create groups for our wines data. If we look at the results, so we will see that we have the original data, and in the end we have a classification and distance to centroid, which can be used for anomaly detection, for example. So final classification, we have seen we can see 3 clusters are chosen as optimal one. if we go to reporting tables, we have also some additional results computed from this clustering. So we have some profiles of the centroids and some graphs and other tables, which we can also use in our data function. And in the end, we need to decide what will be the output of our data function. So let us say that the output would be only the final two variables in there, not the whole data. We will simply attach these two variables to our existing data in Spotfire later on. So that's our data function. It's defined. So let us save it. Clustering, let's call it clustering. Okay, so it's prepared, and now we are jumping to Spotfire. It's empty. We have only loaded one data set, and you can see it's a different data set. It's a different. It's a data set about the countries. So we have countries, and we have some information about the countries like population, area, GDP, and so on. So we want to apply the same algorithm on our nations data, and we will do that through the data function. So to make it available, we go to Tools and Statistica. This is a extension loaded from which you can download from a delivery for free. And this extension, you can define there where is your data function and other things. So I'm loading the data function from local disk. It's the workspace. So it's not the code, some script. It's the set of these nodes together. And once it's loaded, I will define what I will be using in my analysis from that workflow, because the workflow can be more complex. Okay. So I will be defining inputs in our data. In our workspace, we have only one input, so that's clear. For outputs, we can choose output from every node and also from reporting documents. We have decided we want subset. We do not want select variables, and from the k-means clustering node, maybe we would like to have centroids and maybe some pure statistical information about the ANOVA tests. So let us choose these. And in the middle, there is a parameter section. So you can also choose or transfer some parameters. So you can run your workspace with parameters. We do not need anything from a subset, but we would like, maybe you can see that this structure is the same as the structure of the parameters in this node. So it might be useful if the user will say if user wants cross-validation or not, and maybe if user doesn't want cross-validation, maybe he wants to decide how many clusters will be constructed. So for that purpose, we will need to expose to Spotfire two parameters. One is this cross-validation and number of clusters, and that's it. Done. And in the end, the last step is a window which is the same as you might see in other data functions. It's a definition of what will be transferred to the data function. So matching the inputs and outputs. Inputs, the data, we will be sending the nation's data, but not the whole data set, but only several variables. Of course, we do not want cluster according to the name of the country or region. We want to cluster according to the measured features of the country. A number of clusters and cross-validation. These are these two parameters. We do not want to specify them now, but if you want to create, for example, some action controls for that, you can assign and change these parameters as well. So we will not use them at the moment, and then we need to assign where to put the output. Subset, it's these two important columns, and we will add these columns to our nations table, which means this option. For centroids, we will create a new table, and for ANOVA table, we will create a new table as well. So it's now defined, and the data function is triggered. The input data is changed to our new input data, and you can see it's computed now, and we will see in a minute what are the results. We should have in our data set now 2 new variables, and also we will have 2 new tables in as tables which we can use for our visuals. So if we look at our nations data, we can see we have here final classification and distance to centroid. If we look closely to final classification, we can see that it's not in very nice format. So let us change it to 0 decimal places. That is better. And distance to centroid is okay. So we have some new information which we can play with, and now we want to see some information about the clusters first. So we're going to find a classification. We can choose some recommended visuals like this one. Maybe we are interested about some information about the clusters and regions, which can be this tree map. And if we will use different table, we would like to show or to expose the information about centroids for clusters, because this is some overall information about the centers, about what is the typical representative of the clusters. So we would like to have that. Let me rearrange this a bit. I will change colors to have colors according to the clusters in my visuals, to have everything same in the same colors. Okay, so from the first graph, we can see that we have the algorithm decided that three clusters is the best number of clusters. From the second one, maybe we can see that in first cluster there are typically countries from Africa, and from the last, like the profiles for each cluster, we can see that when the cluster 1 has low values, cluster 3 has large values, and other ways around. So and the orange one is somewhere in the middle. So this is like on the several clicks we have some basic information how our clusters looks like. And now we will, in addition to that, use also or look also at the information which we did not use yet, and that's distance to centroids. We have said that it can be used for detecting some anomalies. So what the recommendation engine here recommends, it's a histogram. Okay, we want that. And interesting is that there is another recommendation where there is distance to centroid together with population, and population is not checked. So this is recommended maybe because there is some correlation between distance to centroid and population. So let us use this recommendation. We will again insert here the same colors. Maybe we will create this. And maybe in the end, we will create a detailed visualization, some table, when we will be marking some points, some countries. We would like to know which countries they are. So if we mark, for example, the countries which are on with the higher value of distance to centroid, we can see that these are also with a high population. And there is the list of these which was chosen as outlying ones or with a large distance to the center of the cluster. So this the left side is about the clusters, the right side is about the anomalies, What we have not used yet is the search table, which is about ANOVA measurements. So if we quickly go there, so this is purely statistical table, and the p-value here means the lower is the p-value, the more important is actual variable for distinguishing the clusters. So if we look at population, we have large p-values, so population is not much distinguishing the clusters. But if we look at infant mortality, for example, this is completely different story. So we can, because we have interactive visuals, we can play with that and we can look population. Really, we cannot see some pattern of the clusters, but if we change it to infant mortality, we can see immediately that cluster 1 is with the high values, and cluster 3 is with the small values. So that was a quick example, really quick. We can play with this data much longer, but to summarize what we have seen here, I have shown you how you can get simply some additional information for your visuals, for your investigation of the data through the Statistica data function. Also, we have seen how easily and quickly you can leverage Spotfire recommendations. Everything was done only on a simple example, but potential combination of these two TIBCO products is huge. So I hope this presentation was useful for you, and I hope you will find this potential in your use cases. And with that, I will hand over to my colleague, David Katz, who will show you advanced anomaly detection example using autoencoders. So David, it's yours.
Thank you very much, Tomas. Let me share my screen and start my presentation. So my name is David Katz. Thanks for joining our meetup. I'm going to talk about the autoencoder and its usefulness in anomaly detection. The topics are really just going to be, I'm going to go over what is an autoencoder and how do you use it for anomaly detection, some of the software tools that are available, and then I'll go into my demo, which will also include some information on setup, which fortunately is quite simple. Our hope is that you'll go to the community site, download this DXP, and try it on your own data. So what is an autoencoder? It's a deep learning network which attempts to create an identity transformation, but it does so with constraints. So if you look at the lower right, we have the schematic diagram where we have the input on the left, the output on the right. We're trying to encode the information into a smaller number of nodes or features, which is very analogous to principal components, where you would normally take the largest few principal components and say that that's most of the variation in your data, and then the smaller components are noise. But here, what we're really doing is, once we reproduce the input, we're looking for the mismatches, the imperfections in how that has been done. And that gives you a quantity that's called the reconstruction error. It basically says how anomalous are these data points. And you can look at that by component or overall or by sample. Just a quick look at some of the tools that are out there for doing that. We in this DXP Spotfire template, we're using H2O deep learning, which is very approachable. It enables you to just stack layers, so it's fairly simple, and there's just a few choices for the type of layers that you have. One of the advantages of the other family on the right under Keras is that it can leverage the GPU very well. I've grouped these together because Keras is one package that enables you to use the same front end, and then for performance purposes, you might use different systems on the back end. And all of those on the right have the advantage not only of the GPU, but you can specify more complex network topologies, but the learning curve is a little steeper. One thing that H2O does very nicely is work with sparse data, which if you're working with text data, for example, is very sparse. And actually, GPU doesn't work as well as the H2O. I also just very briefly mentioned the Deep Water project, which you might hear about, but it's mostly been abandoned in favor of Keras for that type of problem. So TIBCO has looked at a lot of these and created demos and accelerators using different TIBCO products. The one we're going to show today is this first one, and its strength is its very complete ability to do post-processing in a graphical way. There's also a Python-based demo in Spotfire using the Python data function, and also using TensorFlow. So you can also take a look at that on the community site. At the bottom, you have a link to the community site with a single page that sends you to all our anomaly detection demos. We also have the AWS Marketplace offers one of our packages that uses TensorFlow in connection with SageMaker. It has the advantages already set up to run on clusters, and is definitely worth a look. So what is the problem? Let's look at the problem that we're trying to solve. We have a lot of time series from different aspects of our process. Usually I think of this as a factory with a lot of sensors. That's a good application. But anytime you have multivariate time series, you can use this kind of technique. And again, like K-means, the way Thomas presented, this is unsupervised, right? We don't necessarily have labels or not very many labels. So the very traditional way is to look at one time series at a time and say, oh, this has gone out of the normal range by looking at the variance of what has come before. Here we take a cross-sectional approach. So for the analysis that we do, we have these vectors corresponding to individual points. And then the very important time dimension is added in the post-processing. And you'll see how that's done. So let me switch over to the live demo. And this is what you'll see if you download the demo from the community site, or the template from the community site. And it's showing here in Spotfire 10. You can also use it in earlier versions of Spotfire. It'll look a little different. As you can see, Spotfire 10 has the pages or tabs along the bottom. You've got the just a little introductory information about autoencoders. And then the setup is actually pretty simple. You just have to make sure that these packages are available to R. And so what you do is go to Tools, which I can't see because Zoom is on top of me. We go to Tools, Care Tools, and this enables us to go to Package Management. And what it does is it retrieves what is already installed and also gives you this list. But I always just use the default. It's not really necessary to localize for most of us, although sometimes that gives you better performance. And then you have all the packages that are available. You have a search bar, and you just need to go through these four and install each one of them. So that's already been done, but I just wanted to show you that to make your path easier when you go to try this yourself. The next step is to import your own data. Now, I've got sample data in here, and you might want to take a look at that, but most of you will be most interested in loading in your own data, and that's done with replace data table. Now, in previous versions of Spotfire, that's just a menu option, file, replace data table. Right now, it's part of this data canvas, which Michael showed before, but it's got all the tables available and the ability to replace one of them here. So the user table is the one where you would replace it in order to use your own data. And when you choose that, of course, you get database connections, or you got local files that you can look at. So any tabular data can come in here either through one of these connectors or as a local file. And once you've done that, we close up the canvas and take a look at that data. This page is really here for free exploration of the data with any of Spotfire's visualization or analytics tools. But then we get more focused on selecting data for the analysis we want to do. So here, via marking, I've selected a slice of data that represents one factory and one product, and that helps in our time series. It makes sense to look at those one at a time. So then we register that data, basically use this button here to ingest the data. And then there's the step where we define 3 samples. So like in many data analysis tasks, we have a training data, we have a validation sample, and a test sample. Here we do something just a little bit different in that we do it in a time-based manner. So in order to start fresh with the new data that we've put in, we summarize using the time column, the date time column that we select. If there are multiple ones, there'll be a drop down here. In this case, we just had the one. And then we do this based on time intervals. And the reason for that is to prevent overfitting. If you did a random sample, then anomalies in the training sample and the test sample, the validation sample, they'd all show up pretty much as normal elements of this data. But if you wanted to generalize from a training sample, which you can identify this way, and then just by marking, you can identify a validation sample, and optionally, you can have a test sample as well. That actually works better with this kind of time series analysis for anomaly detection. Then, we have whatever data that you've ingested and marked for analysis. We get a nice summary of them, and we have the ability to include or exclude them, or in some cases, we would change the data type. And that's done with this interface here. It's very straightforward to use. And then we'd like to actually go and build a model. And that we have a number of basic parameters that control the building of the model. So the model path is simply where you would write the output to save it for later. The epochs are you know, how long do you train? How many times do you go through the data in your training process? And the hidden layers, this is the way H2O looks for your stack of layers. So we've got 25 input layers and 5 hidden, you know, 5 constriction type hidden layer, and then 25 back to restore or reconstruct the data. And this reflects that sideways hourglass that we saw before. And you can put in any number of these layers. Typically, you want a number that's somewhat larger than your actual inputs. Here, you know, we've selected a dozen or so inputs, so we put in 25. And then I'd say mostly this activation function is should be left at this setting, but you do have these different options of the technical side of building deep learning models. And the learning rate is a good one to adjust so that it's not too small, which would make things very slow, but if it's too large, you tend to not get as good convergence as you would otherwise. So here you can create the model, and you have a couple of diagnostic plots, which can be very useful. This is validation error plotted against the amount of training you've done, and that's extremely important. What you want to see is this kind of pattern where you get a tighter and tighter fit, but eventually you get overfitting, so the error increases. H2O is very nice. It will remember your minimum and use that for the subsequent calculations. Now, we talked about the reconstruction error. So here's a distribution bar chart of the reconstruction error, and we see that mostly you have a small reconstruction error, but at a certain point there are a number of cases which are potentially anomalies because we can't reconstruct them very well. So now we look at this in a time series context. So here is our training sample, and we also can look at the validation and test, and we have these sliders so you can look at it. The thing that I found really interesting about this is that in most cases you don't have isolated points in time where there's a problem or an anomaly. The anomaly tends to build up and last for a while, and then resolve either by intervention or for some other reason. So I like to think of these as incidents. So if I mark this incident here, I get the variable importance, which is actually the contribution to the reconstruction error by each of your input variables. So here we see, you know, even though there are a lot of variables, the ones that really contribute a lot to this particular incident are these top 2 or 3. And by selecting this, we can get time series broken down to either the raw data or the contribution from this selected column, and again, the overall, which is just reproducing this one for reference. So you have a 3-part view of what makes this set of points over here anomalous. So the next step you can do is to say, well, some of these anomalies may happen more than once. If we have a lot of anomalies in our data, maybe it makes sense to cluster them. So first of all, we want to work with these incidents. So programmatically, we can set our threshold, and then beyond that threshold, we can say, you know, do we exceed that threshold over time? You know, for a minimum number of time, kind of like a Western Electric rule. So then we can, you know, if we have enough anomalies to make it worthwhile, we can think about clustering. And here's the elbow plot that is one way that you can decide how many different clusters you want to have, and then look at the k-means output. So here's all our inputs that we want to look at, and here are the 5 groups that we formed, the clusters that we formed, and you see that this is one way to visualize the profiles. Finally, we have the ability to take these clusters and maybe look at those over time. So here's the time series. Each point here represents one of these incidents, and we see that some periods of time have a lot of a single type of incidents, and then maybe over here we have a different group. So that's my walkthrough of this demo. We'll have time for questions, but for now I'd like to turn it over to Helene, who's going to do our community update.
Great, thank you very much. Right. Thanks, everyone. So let me share my screen and wrap up quickly with the community update. This community update is always to support the content that we presented in the TIBCO Analytics Meetup, and I guess your overall journey of making the most out of the software that you use, and specifically the analytics software. So the TIBCO community is easy to access. It's just community.tibco.com. Everyone can join. We do ask you to log in, which is needed if you want to ask questions or provide answers, or if you want to download anything from the Exchange, where you can find the template that David was just showing, for example. There's also an ideas section where you can provide input into the product. So if you have any suggestions for next versions of the product, you can put it there. The wiki provides all the detail on all the tips and tricks and the information that we'd like to share with you. And then you can also access all the trial versions of the software via the community. The other useful link is the Meetup group, where you can find ways to meet with us, not only virtually like you're doing now, but also in person. So there'll be a Spotfire Meetup, for example, in London on February 13, one in Houston as well on February 13th, and one in Aberdeen on the 26th. So please take a look there for options to meet with the analytics TIBCO experts and your peers in person as well. So you'll get all these slides with the links. I'm not going into too much detail, so we have a few minutes left for a question, but there's information on both the Statistica and the Python data function and examples on the TIBCO community. Thomas created a special page highlighting sort of the basic components of the Statistica workflow or workspace, as he explains. We have a full page that links to every single demo and application that we have for anomaly detection. So what David explained to you, all the different software, TIBCO Data Science and Spotfire that we use, including the AWS option, where we use TensorFlow and SageMaker, and TIBCO Data Science to do anomaly detection. I also wanted to introduce you to TIBCO Labs. That's an innovation opportunity on the TIBCO community, everything related to the Connected Intelligence Cloud. So if you're a cloud user and you want to build applications that combine all the different TIBCO products, then TIBCO Labs is for you, and we'll definitely come back to that in one of our future TIBCO Analytics meetups. Also wanted to share with you some very cool links of blogs and demos available for you to try out Spotfire 10. We're really hoping to see lots of you converge to Spotfire 10 if you haven't done so already, and benefit from all the features available on Spotfire 10. So please get in touch if you have any questions about that, and take a look at all of these links. These are some tips to just get the most out of the community. I think the only thing I want to share now is maybe to add the data science tag to your questions. That actually promotes the questions to this TIBCO Data Science team. So if you have a question that is related to the TIBCO Data Science products, you'll get a quicker answer involving our team as well. And don't forget to provide feedback when you actually get an answer. That's always really useful. You'll get a slide with all the links to sort of the favorite or top TIBCO community links to bookmark. So take a look at those. Let us know if you have any questions. Provide feedback through the community as well, to see how we can make this even better for you. And last but not least, I'd like to announce or make sure that you're aware of the TIBCO Now Global Tour coming up this year. Singapore, Chicago, and London, 3 different dates, 3 different locations. So get in touch with your account team from TIBCO if you want to participate, if you want to present, or if you need any further information. We'd love to hear from you. Which brings us to the end of the session, maybe an opportunity to ask one question live. I think we've tried to answer most of the questions via the Q&A already to make up for some time, but we've got 1 minute left. I don't know, or
yeah.
Michael.
So there's I can read one question that maybe Michael can address. Was the Alpine data portion of TIBCO Data Science included in the demo? I think not very much this time. Can you speak to how it fits in and how it would be used? Michael, do you want to take that?
You may need to unmute.
Sorry about that, everybody. So can you hear me now, Elaine?
Yes, yes, we can.
Yeah, very good. Yes, so I did want to draw quickly people's attention. If you want to get started with the parallelized Python version running through TIBCO Data Science for anomaly detection, we're offering a free trial for TIBCO Data Science on AWS at the moment. And as David pointed out, this includes our point and click TIBCO Data Science Teams environment, formerly Alpine, and some significant enhancements since the Alpine acquisition. Some of this was highlighted at the recent reInvent conference with AWS. There's a video and slides available. You can click on those to see the presentation. And this includes calling out from TIBCO Data Science Teams and invoking SageMaker to run a parallelized implementation of the Python notebook for anomaly detection. Now that anomaly detection Python notebook is also available for use, available through AWS. You see here the autoencoder for anomaly detection, as well as downloading from our local community site from the links that you were provided today. So we've tried to today give you a variety of options for anomaly detection, a basic from your Statistica, local in-memory application, out on into Spotfire calling into TIBCO R for running autoencoder libraries, and then out through TIBCO Data Science Teams in AWS for running a parallelized version, combining point and click from TIBCO Data Science with Python Notebook interface, for running that through TensorFlow on a clustered distributed compute environment. So thanks everybody for coming along today. There's a lot of information in the slides that you'll get and a number of links that will allow you to download things to try them out. And I think with that, we're going to wrap up, and we look forward to having you on the next TIBCO Analytics Meetup, where we'll be featuring Spotfire 10, along with the TIBCO Data Science Teams, formerly Alpine, web-based distributed compute, in some of those things you might be able to try out before our next meeting. Thanks, everybody. Have a good rest of the day.